Okay, today let's talk about reading and writing equations. So let's first review solving equations. So here we have two-step equations to solve. So let's see if we can remember what to do. First thing we have to do is we've got to think about this in terms of order of operations. In an order of operations problem, I'm looking for an answer. But in an equation, we already have an answer. So what we really have to do is take order of operations and reverse them. And that's how we solve for what I don't know. So the first thing that we need to do is get rid of the plus 8, because that was the last thing that we did when we got an answer, was we did our add subtract. So the first thing I need to do is get rid of this plus 8. And the way we do that is we add its opposite. So this should look like 3m plus 8 plus negative 8, because that's the opposite to get rid of that 8. And if I add something to one side, like this negative 8, I must add it to the other as well. So I add a negative 8 on this other side also, making sure that I've got negative 8 on both sides. Now the purpose for doing that is to make these 8s with this letter go away. So they go away and they turn to a 0, and I'm left with, on the left, 3m, which is equal to, and now we come to the right side and we do the math. 32 take away 8, or 32 plus negative 8, which we know gives us 24. Now I need to get rid of a multiply. So here it says I've got 3m's, and 3m's equal 24. But I don't want to know about 3m's. I only want to know about one of them. So to turn a 3m into a 1m, we just divide it by 3. And that becomes a 1, because the 3's divide out and become 1. And if I do that to one side, I have to do that to the other. So we end up with 24 divided by 3 equals 8. So if I were to plug this 8 back into the original problem, 3 times 8 is 24, plus another 8 gives us 32. So it works. Now in this one we have a divide by 7. The only thing that will make a difference is whenever we're doing the last part of it, like here we did a multiply by 3, so I did a divide by 3. Well, here I have a divide by 7, so that means I have to do a multiply by 7 to get rid of it. But everything else is still the same. So we start here with this minus. We don't like minus, so we're going to change it to a plus and next number to its opposite. And this is to prevent careless mistakes. So here I've got k divided by 7 plus negative 9. But to get rid of the plus negative 9, I have to add a positive 9. And if I do that to one side, I must do that to the other as well. So my 9's go away, and I'm left with k divided by 7 is equal to negative 14 plus 9, which we know is going to give us a negative 5. Now, how do I get rid of a divide by 7? Because what this says is 1/7 of a k is equal to negative 5. But I don't want 1/7 of a k. I need a whole k. So I need 7 of these pieces in order to get a 1. So we multiply it by 7. We multiply the other side by 7 as well. And we find out that k is equal to negative 35. So if I were to take the negative 35 and plug it back in, negative 35 divided by 7 gives us a negative 5. And then negative 5 minus 9 will give us a negative 14. So that's how we solve equations. That's how we do those. So let's talk about reading and writing, because that's where we're at. Well, what have we done so far with reading and writing? Well, what we did a few days ago was we talked about reading and writing expressions, where we would take each one of these expressions and translate them into an algebraic expression. So a language arts phrase into algebra. So this one says 6 more than J. Well, we know that 6 more than means that I'm going to add 6 to something. And in this case, what am I adding it to? I'm adding it to J. So the correct way of writing this one would be J plus 3. The product of, well, product means that we're multiplying, and it means we're going to take the next two things and multiply them together, because we're going to put the multiply sign where the and is. But in multiply, we need to remember that this number, the coefficient, will always go first. So this should be 3t, and then it says plus 15, so plus 15. Now the last two, what I want you to do is change the expression into a language arts sentence. And I want you to be as literal as you possibly can. So in this one right here, we would say this one as 4 times r minus 6. And that's the easiest way to say that. Okay, the second one is 8 plus m. That's the easiest. Now, that's not the only way to say it, but that is by far the easiest way. So now what if we turn this into equations? With expressions, we know that we don't have an equal sign. With an equation, we do have an equal sign. And the word that represents equals is the word is. So if we have 5 more than a number is 6, we have one expression, and then we have equals the other expression. So 5 more than a number, well, if it says a number, we can use any letter we want. So I'm just going to use X or N, whichever one I put up here. 5 more than means I'm going to add 5. I'm adding it to a particular number, N, and it's going to equal 6. So here's the equation that we have. Okay. Second one says the product of 7 and B is equal to 63. Well, product again means that we're multiplying. So the next two things that come along are going to be what we multiply. And the and tells us where our multiplication symbol goes. And in multiply again, the number goes first. So this would be 7b. And then is our equals. And it's is equal to 63. So 63 is the other side. Okay. Next one says the original price decreased by $5 is 34. Well, the original price, we don't know what that is, so we just use a letter to represent that. And it's decreased by $5. So we could say price decreased by $5 is $34. And there's our equations. So again, if we use that direct translation method there, it makes these things a lot easier to write into actual equations. But now in the real world, unfortunately, it doesn't come like this. It comes more like this. Okay, so it says it's in a word problem. So Julia is 3 years younger than Kevin. Kevin is 13. Define a variable and write an equation to find Julia's age. So we need to figure out what's unknown. Well, down here it says exactly what our unknown is. It says define a variable to write an equation to find Julia's age. So Julia's age is what I don't know. So Julia, we'll represent it with a J. Because typically you'll use a variable that's associated with what it represents. And it says Julia is 3 years younger than Kevin. Kevin is 13 years old. Define a variable and write an equation. So we need to write this equation. So it says, what do we know? Julia is 3 years younger than Kevin, and Kevin is 13. So there's a couple of ways that we can write this. One way is I know that Kevin is 13 years old, and Julia is 3 years younger than that, which means I'm going to subtract 3, and that would be equal to J. Or I could take 13, and I could subtract Julia, and I should get 3, because it does say that Julia is 3 years younger. So if I take Kevin's age, subtract Julia's age from it, I should get 3 as an answer. And that's what we're doing today, taking things like this, word problems, and translating them into equations. Let's look at another one. In a library, the San Diego Public Library has 44 fewer branches than the Chicago Public Library. Define a variable and write an equation for the number of branches in the San Diego Public Library if Chicago has 79 branches. So the thing that I don't know is I don't know the San Diego Public Library. So what we're going to use, we're just going to use the letter S to represent San Diego because we need to use a single letter. Now it says the San Diego Public Library has 44 fewer branches than Chicago. Okay, so we know Chicago has 79, so we could say that San Diego, which is what our variable is, has 44 fewer branches. Well, 44 fewer means that we're going to take whatever San Diego is and subtract, or has the 44 here, it's less than what Chicago has. So if we were to take the Chicago, which is 79, if we were to subtract the San Diego, we know we would end up with 44 branches that remain, 44 fewer. San Diego has 44 fewer branches. Okay, so that is one way we could do it, or we could actually write this as 79 minus 44 equals how many we have in San Diego. So either way is acceptable. Well, what if we have two-step equations? So those are all one step, but what about two-step equations? So in this one it says 4 more than 3 times the number is 19. Well, we know 4 more means that I'm going to add 4. Okay, what am I adding it to? 3 times the number, so that's going to be 3n. And it all equals, because is means equals 19. So 3n plus 4 equals 19. Okay, 5 is 7 less than twice the number. 5 is 7 less than twice the number. So we know 5 is going to be the equals part. So 5 is. Well, what is it? 7 less than. No, I know that means that's, oops. I know that means that it's 7 less than. So subtract 7. It's 7 less than what? Twice a number, which means I'm going to multiply that number by 2. So 5 is 7 less than twice a number. Okay, the last one down here says 7 more than the quotient of a number and 3 is 10. Well, 7 more than means I'm going to add 7. Well, what am I adding 7 to? I'm adding it to the quotient, so I know I'm going to be doing some division. Okay, and what am I dividing? A number and 3. So that's going to be n over 3, and that is equals 10. 7 more than means I add 7 to this division problem, a number divided by 3, and that is 10. So here are some two-step equations that we have the same thing. Now what if we had these in words? A word problem. Carlos is building a screen door. The height of the door is 1 foot more than twice its width. What is the width of the door if it is 7 feet high? So we need to do the same thing that we did in the 2 previous word problems. We need to define a variable. What is it that I need to know? Well, the question says what we need to know. What is the width of the door? So width is what we're missing. So it says up here, it says the height of the door is 1 foot more than twice its width. Okay, so 1 foot more means that we're going to add 1. So that's the 1 foot more. Then twice its width. So that means we've got 2w. And this is what height is. And it says that the height then is 7 feet equals 7. So the height of the door is 1 foot more, which is this right here. The 7 is the height, is 1 foot more than twice its width. So here is the equation that we would use to solve for width. One last one. Ella swims 4 times a week at her club's pool. She swims the same number of laps on Monday, Wednesday, and Friday, and 15 laps on Saturday. She swims a total of 51 laps each week. So how many laps does she swim on Monday? So we need to write an equation for this in order to solve it. Okay, we're focusing more on the equation than we are the solving part. So Ella swims 4 times a week. So we know we've got 4 things. Okay, at her club's pool. She swims the same number of laps on Monday, Wednesday, and Friday. So Monday, Wednesday, and Friday we know are going to be the same. So we could represent that with L, number of laps. So we could have on Monday, she swims L laps. On Wednesday, she swims L laps. And on Friday, she swims L laps. Okay? And then on Saturday, we know she swims 15 laps. And we know that the total is 51. So I know that if we put Monday, Wednesday, Friday, and Saturday together, we will end up with 51 laps. So we've got L plus L plus L for Monday, Tuesday, and Wednesday that all have the same number of laps, plus 15 is going to equal 51. So what could I do with these L's right here? Well, how many L's do you see? 3 of them. So we write it as 3L plus 15, and that's equal to 51. And if we solve for L, we will find out how many laps she did on Monday. So that's how we read and write equations.